Hey everybody, thanks for clicking on this video. Today we're going to be practicing indefinite integrals with exponential U-substitution. If you want to follow along, the links to the companion worksheet are in the description below. Also, if you want to see more videos like this, click the subscribe button to stay up to date on all the videos we have coming out from the channel. So let's get started. So with U-substitution, we want to first identify what is the inner function, because U-substitution with integrals is really just chain rule backwards. So for this one, we can easily see that e to the x is inside of sine. So that means u equals e to the x. So we'll make that replacement e to the x sine of u dx. So next what we do is now we take the derivative of this and we write this as du equals e to the x dx. So we see that e to the x and dx can both be replaced by du. So now we write this as sine of u du. So now that everything is in terms of u, we can take the antiderivative. So the antiderivative of sine is negative cosine of u plus c. So that means that this answer is negative cosine of e to the x plus c. Now for the second one, when you're dividing two quantities, what I always recommend is you write these two quantities out separately. E to the x minus e to the negative x times 1 over e to the x plus e to the negative x dx. And so what's going to happen is we have to pick one of these to represent u. And so for the sake of this example, we'll try them both. So over here, we'll say u equals e to the x minus e to the negative x. And over here, we'll set u equal to e to the x plus e to the negative x. So when we rewrite our integral, this is going to be u times 1 over e to the x plus e to the negative x dx. And here, this is going to be e to the x minus e to the negative x times 1 over u dx. So far, so good. Let's keep going. We take the derivative over here. Du is going to equal e to the x plus e to the negative x. Over here, whoops, forgot the dx. Over here, du equals e to the x minus e to the negative x dx. Now here we've got e to the x minus e to the negative x, and we've got the dx. So this replacement can happen. Now here we don't, because this is 1 over e to the x plus e to the negative x, where this one isn't. So that means this doesn't work. Instead, it's going to work like this. So we replace that, so we have 1 over u du. So now that it's all in terms of u, we can take the antiderivative, which is ln of absolute value of u plus c. And so when we replace u, that's going to be ln of e to the x minus e to the negative x plus c. On the next page, here we have 4 to the x plus 1 on the inside. And so this is going to be related to e to the x. This is going to be u. U equals 4 to the x plus 1. So we're going to have 4 to the x times the square root of u dx. So we take the derivative of u, so du. Now 4 to the x works a lot like e to the x, with one exception. Just like e to the x, its derivative is e to the x, so is 4 to the x, but we multiply that by ln of the base number, ln of 4 dx. Now we have the 4 to the x, we have the dx, but we don't have the ln of 4. So to make this work, we're going to divide 1 over ln of 4 to the other side. So now when we replace that, we're going to put the 1 over ln of 4 out front, because coefficients don't really affect integrals. So u under the square root is the same as u to the 1/2. So that's going to be, this coefficient's going to follow with it, 1 over ln of 4 times, so u to the 1/2 becomes u to the 3/2 times 2/3 plus c. So now we'll combine these two coefficients, so 2 over 3 ln of 4 times the square root of quantity 4 to the x plus 1 cubed plus c. All right, number 4. Now this one is very similar to number 2. So first I'm going to rewrite it separately. E to the 2x times 1 over 1 plus e to the 2x. And so more often than not, when you have a numerator and a denominator, it's the denominator that's u. So u equals 1 plus e to the 2x. So that means we have e to the 2x times 1 over u du. So we take this derivative, so du equals 2e to the 2x dx. Now we have the e to the 2x, we have the du, but we don't have the 2. So the 2 has to go over to the other side. So 1/2 du equals e to the 2x dx. So the 1/2 is going to go out front of the integral. 1/2 times the integral 1 over u du. So that's going to be 1/2 ln of the absolute value of u plus c, which is 1/2 ln of 1 plus e to the 2x plus c. Now number 5. Now we can say that e to the 4 minus 2x is the inside function, but we can actually simplify this because ln and e cancel each other out. They're inverse functions. So that means we just have 4 minus 2x dx. So our antiderivative is 4x minus x squared plus c. Thanks for watching. If you liked the video, give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.